Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff.
To talk about minerals, and the first thing you need to realize, there are lots of minerals in the world, 2,000, more than that, identified in the world, but very few of them are common. Just if you think about it like clothing, you know, there's a lot of colors of clothing you can wear, but I bet you if you looked around when you get to school, you'd find that most people either have some black, blue, or white on. Now, why is that? That's because people usually share a common clothing color, those being the three that I just mentioned. The same thing happens with minerals. Most rocks have a couple minerals that will usually be in them. Quartz, feldspar, mica, olivine, amphibole, calcite. These are some of the rock-forming minerals. And these are minerals that, you know, of that 2,000 or so are normally in rocks. When we're looking at minerals, one of the things we want to do is identify them. We want to be able to look at them, do a few tests, and look for a few things and figure out what the heck mineral is that. And we do this by looking at their physical and chemical properties. Now, there are several physical properties that you need to be able to identify through a test. Now, what you need to realize, most people will look at a mineral and the first thing they're like, oh, it's great, look at that, it's purple, it's yellow, it's blue, it's white. Although color is a good characteristic because it's the first thing you see, you have to realize minerals can have a number of colors. So like calcite can appear gray, it can appear clear, it can appear white, it can appear orange. Similarly, there are a number of minerals that can appear clear or white, like quartz and calcite and halite. So color isn't a great thing to use. Better than color is something called streak. And to identify a mineral's streak, we use a streak plate. It's a little piece of porcelain, and you just drag the mineral across the streak, and it will leave a color, or there'll be no streak. If there's any impurities on the mineral, like if the mineral is oxidized or rust, the streak plate will take that off and give you a clear indication of what the mineral is. So that's the first thing we do. Another thing you can look at is how a mineral breaks. And a mineral will break one of two ways. If it breaks irregularly, it'll be said to have fractures. So if it doesn't have any parallel surfaces, the mineral is said to have fracture. Now, if a mineral breaks very regularly at certain angles or with parallel surfaces, that mineral is said to have cleavage. And that is due to the internal arrangement of the atoms. In fact, all the physical properties we're going to talk about are due to the internal arrangement of the atoms inside that mineral. So, after those two, we start to look at a mineral's hardness, and that's its ability to resist scratching. Now, there's this guy, Friedrich Mohs, who came up with a hardness scale, and basically what he did is he scratched a bunch of minerals against each other, and he found out which one would scratch which, and he came up with this scale. The softest mineral on that scale is talc, and you probably know talcum powder. It also goes by the name baby powder. And the reason you'll put baby powder on your skin is because it's very soft. It won't scratch you. The hardest mineral we know of is diamonds. Diamonds are extraordinarily resistant to scratching. Almost nothing will scratch a diamond except for another diamond. So what you do to test that is you take a piece of glass and you put it on the desk and you press hard on it to see if the glass is scratched or not. If the glass is scratched, the mineral is harder than the glass. If the mineral does not scratch the glass, the mineral is softer than the glass. There are some other things we can look at, including the specific gravity. So some minerals are very dense. Like if you pick up a piece of galena, even though it might be a small sample, whenever I pick it up, I'm like, wow, for a small thing, that really weighs a lot. And that's because it has a high specific gravity. Besides the physical tests you can do, streak, luster, which is how it reflects light, and it'll either look like a metal, which means it's metallic, or non-metallic, which means it can be shiny, but it does not look like a metal. So we've got streak, luster, hardness, how it breaks, cleavage or fracture. We can do some chemical tests. The most famous of these is the acid test. And if you put up acid on some minerals, it will react. And you'll see this with some bubbling or fizzling. The most famous one that you need to remember is calcite. When we're studying things, a lot of times the Regents exam, there'll be, a student took a rock and put some hydrochloric acid on it and it started to bubble. What mineral is in there? You need to put in your brain that if there's bubbling or fizzing, most likely the mineral that's causing that is calcite. Along those lines, there are some other special properties. Halite is a mineral, and you probably have eaten some halite in your life. Halite is also salt, so it has a very salty taste. Please do not go around tasting minerals. It's not a good way to test for that. Another thing is some minerals, when you put a black light on them, they will fluoresce. And that's a really neat property, and it's due to some of the elements in there that when that black light passes over them, they'll give off some visible light, and it'll look like they glow in the dark. Other minerals are radioactive, and we try not to hang around with these too much because radioactivity isn't the best thing to come in constant contact with. But scientists will use a Geiger counter to measure and see if radioactive elements in it. Anyhow, there'll be some more videos coming up later about how to do these individual tests, ladies and gentlemen. But for now, hopefully you'll be able and comfortable to identify and test a mineral. If you need some help, look at page 16 of your reference tables. That's the back cover. There's a whole page devoted to minerals, so check that out, ladies and gentlemen. And if you need anything else, you know where to find me. Wits mail me or ask me in class. Take it easy.